Okay, Muhammad Ali, I'm going to unmute you. Do you want to share your screen? Okay, Muhammad Ali, I'm unmuting you. Yes, Muhammad on. Yes. So Muhammad Ali is going to explain us this question. I'm going to share my screen with you.
Yes, ma'am. Ma'am?
Yes.
Ma'am? How we will, you will share the screen or we will read the questions?
Do you have to show something? Do you want to
No,
share?
ma'am. No.
Okay, so then I will share. Okay, so let me share. I'm sharing my screen. Okay, I'll show them the question that you're doing. Okay.
Okay, ma'am.
Okay, good job. So this question, Muhammad Ali is gonna solve this question. This is question number 1 on page 28. Okay, Muhammad please be sure that you don't have background noise. Okay, Jazakallah khairan. So now let's get started. So read the question and please answer it.
Yes, ma'am.
Okay.
First, we have to explain that how many types of particles there are in an atom. So
Very
there
good.
are 3 types of particles in an atom.
Okay.
Number one, protons. Number 2, neutrons. And number 3, electrons.
Very good. And where do we find the neutrons and the protons? In which
They
part of
are,
the
they
atom?
are, they are like inside the nucleus.
Very good. Nucleus is the central part of the atom. And where are the electrons? Where do we find the electrons?
And electrons are found outside. They are traveling at so fast speed that you can also not see them.
Very good. We cannot see them and we just, yeah, they're just buzzing around so fast around it. Okay, let's move on to the table.
Now we have to explain the table to show their mass and their charges.
Very good.
First, we will explain subatomic particle.
Very good.
Protons is the first subatomic particle. The second subatomic particle is neutron, and the third one is electron. The
Okay.
charges are, for proton the charge is 1 plus. For neutrons there is no charge, it is 0. And for electron their charge is 1 minus.
Right. So how did you decide that the second one is a neutron? How did you decide that the second blank in the subatomic particle column is a neutron? How did you decide on that? Because yes, because the charge is 0, right?
Yes, because there is no charge in between.
Right.
And
Right. So that means it's a
after it there is an electron which has 1 minus charge.
right. And then how did we decide that the last blank in the subatomic particle column is an electron? How
Because
did we
it
decide?
has 1 minus and the first one was 1 plus. So in
Right, because
between 1 minus and plus there is a 0.
yeah, you know how we decided that the last blank in the subatomic particle is electron because its mass is almost
Almost
0.
0. There's nothing
Right.
in it. Almost.
Right. So there is some mass, but it is so small that we can easily neglect it, and it is almost equal to 0. Okay, not exactly equal to 0, but almost, right? Compared to the mass of protons and neutrons. Okay, good job. Now let's do the fill in the blanks.
The fill in the blanks. First of all, the fill in the blank which I am going to tell is the protons and neutrons are found in dash of the atom, while the nucleus.
Very
Ma'am,
good.
I would like to ask this question from all of the participants who are attending the class.
Okay. So who wants to answer? Muhammad On has asked a question. What will come in the first blank? That protons and neutrons are found in the dash of the atom called the nucleus. Harim Khayyam. Harim Khayyam, I'm unmuting you.
अच्छा वॉशरूम में होंगे
Yes, hello.
So, yes. So what will come in the first blank? Protons and neutrons are found in the dash of the atom called the nucleus.
The answer is
Do you
the
have the
center.
question?
The center
Yes.
of the atom.
yes
Very good.
this is
Very
the
good.
correct answer.
Yes. Okay, good, good. Okay.
The
Okay.
dash zoom around the nucleus in shells.
The dash zoom around the nucleus in the shells. Okay, Saad, I'm unmuting you. Yes, Saad? Saad, I have unmuted. Okay. Ayla Hamid, I'm unmuting you. I can't
Yes,
see you.
hello.
Yes, yes. Okay, so you want to fill in the next blank, the dash zoom around the nucleus in shells. Muhammad
The
On.
electrons.
Very good. Good job.
Ma'am, it is
Okay.
the correct answer. The last and
Yes.
the final blank will be the first shell, which is dash the nucleus, can hold dash electrons, whereas second and third can hold dash and dash.
Very good. Okay, so who's going to answer this? Vania Mohsen. Yes, Vania Mohsen. Would you like to fill in these blanks?
Yeah, miss. It's
Okay.
near. The nucleus can hold 2 electrons, whereas the second and third shells can hold 8 electrons.
Okay, but what is the answer for the first blank? The first shell, which is dash the nucleus.
Near.
Right, which is the closest to the nucleus or which is next to the nucleus. Yes, okay. Okay, Muhammad On, you did a wonderful job. I'm so proud of
Now
you.
I would like to ask the questions. There are some questions.
Okay,
What is the atomic number of an atom?
right. We're doing this question now. What is the atomic number of an atom? Okay, Muhammad On.
Yes,
So,
ma'am.
okay, are you answering or are you asking?
Ma'am, I'm asking.
But I asked you to answer. Remember?
Okay, ma'am. Now I will
Okay.
tell the answer of it. It is only one.
Okay, okay. But if you want to ask your friends, it's okay with me. You want to ask your friends what is the atomic number of an atom? Let's see if they know it.
No,
Okay.
ma'am. Now I will ask them the next number.
Okay. So you want to answer part A?
Yes, I have already answered part A.
What was that? I didn't hear you. Can you repeat?
1.
What is the atomic number of an atom? And the answer is
1.
how come? Can you explain? Yes. It's okay. It's okay if we make mistakes. We are here to learn. It's okay. We will learn from our mistakes.
Because the atomic number of an atom is because the atom is alone, and one atom is equals to 1.
No. Okay, let's ask your friends. Okay, let's ask.
Who can answer my question?
Yeah, but you know, this answer is not correct. Okay, let's ask Umar Arshad. Maybe he knows. Umar Arshad, I've unmuted you.
Ma'am?
Yes, I'm trying to. Yeah, Umar Arshad. Yes, Umar Arshad.
Yes, ma'am.
Yes, can you answer this question? What is the atomic number of an atom?
Atomic number of an atom is
Yes. Yes.
Miss 2.
No. No. It's okay. It's okay. Don't get worried if you get your answer wrong. Okay. Saeed Khan. Yes, Saeed Khan. You want to answer this? What is the atomic number of an atom?
Yes, teacher.
Yes.
The atomic number of an atom is the identification,
Very
and
good.
it's the protons of an atom, the amount of protons.
A number of protons in the nucleus of an atom. Okay, make your answer specific. Yes, you are correct. Atomic number of an atom is the number of protons in the nucleus of an atom, and it is the identification number for an atom, right?
Yes.
Right. So two atoms can have the same number of neutrons, two atoms can have the same number of electrons, but two atoms, two different atoms cannot have the same number of protons.
Protons.
Right. So that is why we use the number of protons as the identification number. So two different atoms. Yes. Okay.
Because electrons keep on changing.
Right.
And neutrons, many of them are same and many of them are different.
Yes.
So people get
Yes.
confused.
Yes. Did you attend my last class? The class on atomic structure?
Yes.
Yes. Very good. Yes. Okay. Now.
Then I would like to ask the second question. What is
Okay.
the mass number of an atom? Ma'am, can
Yeah.
I answer it?
Let's give others a chance. Okay, Saeed Khan?
Okay, ma'am.
Yeah, very good. Jazakallah khairan. Okay, Aisha.
Mass number is the number of protons and neutrons added. The sum of
Right.
protons and neutrons in an atom.
In
Yes,
the nucleus
ma'am.
of an atom. Yes.
It is the correct answer.
Yes, correct answer. Okay,
Because electrons do not have any weight almost.
very good. Good job. Because electrons have negligible mass, so we don't include it in the mass of an atom. Okay, part C. Okay, Muhammadan, you ask.
What is the atomic number of the atom below?
Okay, who is going to answer?
Ma'am, may I answer it myself?
You want to answer it yourself?
Yes, ma'am.
Okay, okay. Go ahead.
The below atom is the short form of argon, and its total amount of atomic number is 18.
Very good. So 18 is?
18 is the correct answer of argon atomic numbers.
Very good. 18 is the atomic number, right? And
what
then
is its mass number?
40 is the mass number. So how did you decide on that? Can you explain us a little? How did you decide on that? I mean, you have two numbers. So how did you know that which one is the atomic number and which one is the mass number?
The mass number I decided.
Yeah.
How did I decide the mass number, and how did I decide the atomic number? First of all, I would like to say that the answer of the atomic number below I got because I was learning the formula, so I also was thinking myself that argon cannot have so much amount because it is not so much. It does not have so much amount of atomic numbers, so maybe it would have 18.
Right. Okay. Okay. I am going to. Okay. Jazakallahu khairan, Muhammad. You have done a wonderful job. Okay. Mashallah. Barakallah fi. Okay.
Thank you, teacher.
You're most welcome. Okay. So I'm going to start my video. I just want to emphasize on this point a little bit more. So when you have something like this, when you see something like this in the periodic table and you have two numbers at the top and the bottom, remember the smaller number is going to be the atomic number and the bigger number is going to be the mass number. And that only makes sense because mass number is the sum of the number of protons plus the number of neutrons. So protons plus neutrons will give us the mass number. Okay, that's why this is the bigger number, because it is a sum, it's bigger. The bigger number is the mass number. Atomic number is just the number of protons. Therefore, of the two numbers, the smaller one is always going to be the atomic number, okay? Which is the identification number for an element, okay? Now, Abdullah. Abdullah, are you here with us? Let me search Abdullah. Okay, yes, Abdullah. Now it is your turn. Do you want to share your screen? Okay, let me stop sharing. So Abdullah will do question number 3 with us. Give the numbers of protons, electrons, and neutrons in the atoms below. Have I unmuted you? Let me unmute you. I have unmuted you. I can't seem to unmute you. You're not getting unmuted. Have you muted yourself? Okay. Let me. Abdullah, I am muted. I am trying to unmute you, but you're not getting unmuted. Just check that you have not muted yourself. You're not getting unmuted. Okay, there's some problem. Okay, we'll try later. Okay, let me ask Javeria. Javeria, are you there? Okay, Abdullah, I'll give you a chance later, okay, after Javeria. Where is Javeria? I cannot see her. Yes. Yes, I saw her. Okay. Yes, Javeria. Wa alaikum assalam wa rahmatullahi wa barakatuh. Okay. So, do you want to share your screen or is it okay?
I'm going to share my screen.
Okay. So, let me.
Give me a second.
Okay, I allowed you. I allowed you. Now try sharing your screen.
Can you see?
Okay, let me. Yes, yes, we can see you. Yes, okay.
So I'm going to be solving question number 5. So
Okay.
over here we need to tell the atomic number, sometimes electronic structure, and sometimes the element. So first of all, we have lithium, and we know that the electronic structure is in the first shell it's 2 electrons, in the second shell there are 1 electron. So we know that the electrons are the same as the protons. So we know that the atomic number is going to be 3.
Okay.
And
Okay. Okay, Javeria, we are listening to you.
okay. And next we have atomic number 14.
Right.
Now, if you look into the periodic table, or if you know
So, so Javeria, how did you write 3 in there in the table?
it's because the we know that the electrons.
Okay, Javeria is solving question number 5. Okay, for everybody, Javeria is solving question number 5, the end of chapter questions for the second chapter. For the third chapter, which chapter is this? Okay, it's on page 38. Okay, atomic structure. Okay, so how, Javeria, how did you write 3?
It's because the lithium's atomic number is 3.
Right. No,
And
but how
even
did you?
even
Yeah.
without looking into the periodic table, you can tell because the electrons are same as the protons. The number of
Right.
electrons is the same as the number of protons. So if there
Yeah,
are
because
3 electrons, there are going to be 3 protons.
yeah, in a neutral atom, right? Because we are talking about a neutral atom here. So in a neutral atom, the number of electrons is going to be equal to the number of protons, right? Okay, go ahead.
Next, we have the atomic number 14. We're not given the electronic structure or the element. But if you look into the periodic table, you'll know this element is silicon. Silicon. You can see
Okay.
over here. This over here, this is silicon.
Okay. Atomic number 14 is silicon. Okay, you are correct. Okay.
Next, we need to write the electronic structure. Now we're gonna go shell-wise.
Right, and then also tell them that because this is a neutral atom, so you have the same number of protons and electrons. So you're going to have 14 electrons. So how will you divide them? 2 in the innermost shell, followed by 8 in the second shell. So that makes 10. And so we are left with 4.
Yes.
Right. So that gives us an electronic configuration of 2, 8, and 4. Okay.
Next,
Okay.
next atomic number we have is 19. And if you look into the periodic table, 19 is potassium.
Right.
It's potassium. Even if you've learned the elements, you'll know that this is potassium.
Yeah, you don't have to learn, but you know, with the passage of time, you will learn, but you don't have to. And periodic table will always be provided to you in all your exams, tests, and everywhere. I mean, it will be provided to you. So don't worry learning their atomic numbers and mass numbers. You don't have to.
Let's
Okay.
move to the electronic configuration. In the
Okay.
first cell,
So now we will
8
have 19 electrons because this is a neutral atom. So again, 2 in the innermost shell, followed by 8 in the second shell. So that makes it 10, and then we are left with 9. But can we have 9? But can we, Javeria, can we have 9 electrons in the third shell?
Yes.
Are you sure? No.
Yes. I'm sure.
No. In transition metals, maybe, but no. We're going to have 8 electrons in the first as well, in the second as well as third shell. So it's going to be 2, 8, and then 8, and then 1. Okay. And also Javeria, and that's fine. This is the learning process. Yeah, this is why I asked you to do these questions for me, because I want you to think. I want you to think and learn from your mistakes. So that's absolutely fine. You did a fabulous job. So yes, so 2, 8, 8. So that makes 16, 17, 18. So we have 1 left. So that 1 electron will go in the outermost shell. That's right, right. So now in which group is potassium placed in the periodic table? In which group is it?
In the first group,
Right.
alkaline metals.
Right, and if you remember from my first 2 classes on atomic structure, remember I mentioned that the number of group represents, what does the number of group represent? Do you remember?
The number of valence electrons in the last shell.
In the outermost shell, exactly. So if it's in group 1, it should have 1 electron in the outermost shell, right?
Yes.
Right. So does that make sense? Good.
Yes.
So Javeria, you've done a fabulous job. I love it. Keep it up. Okay, Jazakallahu khairan. So I will try Abdullah. I will try again muting Abdullah. Okay, Jazakallahu khairan. You're most welcome. Thank you. Okay. Okay, I will try unmuting Abdullah again. Okay, are you, I can see 2 Abdullahs. Abdullah Khan 6C. I cannot unmute you, Abdullah. I don't understand why. What's the problem? Okay. Okay. Okay, let's move on to, okay, now let's move on to the further questions on page 65, and then, okay, so, Sariha. Sariha. Yes, Sariha. Yes.
Yes, miss.
Yes, it's your turn. You had to explain us question number 16.
Yes, miss. Miss, I have to share screen.
You have to share screen. Okay. Okay, I'll allow you to share your screen. Try sharing it because I have already allowed.
Miss, can you see my screen?
Yes, yes, I can see your screen. Good job. Yes.
Okay, so I'm going to tell question 16.
Okay.
First I'm going to tell that which type of elements are in this table: oxygen, chlorine, gallium, zinc, and tungsten.
Very good.
And their atomic number and mass number is given.
Okay.
Now I will read question A. How many protons would you expect to find in an atom of oxygen? The highlights are how many protons in oxygen. This question is saying that how many protons are in oxygen. Now here, we know that atomic number equals to the number of protons. So
Very
atomic
good.
number of oxygen equals to 8. And
Very
the
good.
atomic number stands for protons. So the protons in oxygen are also 8.
Very good.
Next
Very good.
question.
Okay.
Next question is question B. Where in the atom would the protons be found? This is an easy question. Protons are found in the nucleus.
Very good. Wonderful.
Thank you. Now, question C. How many neutrons would you expect to find in an atom of zinc? Look, mass number equals to protons and neutrons, and atomic number equals to proton. So mass number subtract atomic number, neutron and zinc. 65 subtract 30, answer equals 35. So it means that there are 35 neutrons.
Very good. Yes. Okay.
The last question, question D. Which element in the table above has atoms which contain the same number of protons as neutrons? So let's see. We are going to subtract the mass number with the atomic number. First, let's do for oxygen. 16 subtract 8 equals 8. Chlorine, chlorine. 35 subtract 17 equals 18. Gallium, 70 subtract 31 equals 39. Zinc, 65 subtract 30 equals 35. Tungsten, 184 subtract 74 equals to 110. So we can tell that which one has the same protons as neutrons. It is oxygen.
Right. Because in oxygen only, you have the same mass number as the atomic number. I mean, so sorry, the same neutron number as the atomic number, right?
Yes.
Okay. So good job, Sariha. You've done a wonderful job. You guys have prepared beyond my expectations. Good job. Okay.
Thank you,
Miss. You're most welcome, and thanks to you. Okay, Momina. Momina. Yes, it's your turn.
I would like to share my screen.
Okay, yeah, go ahead and share.
So
Yes, we can see your screen.
The question is, use the information given about a sodium atom to complete the table. So
we know that 23 is the mass number and 11 is the atomic number.
Okay.
The table says to tell the number of protons, number of neutrons, and the number of electrons.
Right.
The number of protons and electrons in a stable atom is the same as they both have opposite charges. So it is understood that it is the same.
So because it's a neutral atom, therefore the number of positively charged particles should be equal to the number of negatively charged particles for the
Negatively
atom
charged
to be
particles.
neutral. Right, right.
Yes.
Okay.
And the atomic number tells us the number of protons, which for sodium is 11. So we know that the number of protons and electrons is 11.
Right.
Mass number means the total mass of
Right.
the atom. Electrons have almost no mass, which automatically means that it is the sum of the number of protons and neutrons. As we know the number of protons from atomic number, we simply
Right.
subtract the atomic or proton number from the mass number, which in this
Right.
case is 23 minus 11.
Very
And
good.
the answer is 12.
Very good. Okay. And then, okay, so the number of electrons would be the same as the number of protons. Good job, Momena. Wonderful. Wonderfully done. Okay, those who are not participating, please keep your screens. Don't share your screen, okay? Zorez, where are you? Okay, now it's your turn.
Hello, assalamu alaikum.
Walaikum assalam wa rahmatullahi wa barakatuhu. Okay, you also wanna share your screen or are you fine? Zorez? I can't hear you.
Like to share my screen.
Okay, go ahead. Sidra's iPad, please turn off your video. Who is this Sidra's iPad? Okay. Then Naveed, please turn off your video. Yes, Zorez.
1 minute.
If it's taking too long, then we can wait for you. Okay.
Yes.
Okay. You can even do it orally. I have the question with me. I can show. I can share my screen and I can show them the question. You just explain. We can do it that way too. Are you facing some problem? Okay.
Oops. Drop my device.
Okay, sorry. Okay. Yes.
Yeah, you can share the screen.
Okay. Okay. Let me share. Okay, so Zorez will be explaining us this question, number 18 on page 65. Okay, Zorez, start explaining. Yes. Yes, Zorez. Okay, I'm sharing this picture. Zorez wants to use it for his explanation. Yes. Okay. Yes, I am. Okay, I am sharing my screen. So please keep your eyes on my screen. Yes. Go ahead, Zorez. I'm showing them the picture. Zorez, I can't hear you.
I cannot see the screen.
Here you go. Can you see the screen now?
So it's still black.
I am sharing my screen. I am sharing my screen. You cannot see your diagram, your question? I think you have some Wi-Fi problem. Okay. I think you're having some Wi-Fi problems, Oriz. So let me ask Rayan Rahil. It's okay, Zoriz, it's okay. You can do it later. Okay, Rayan Rahil. Rayan Rahil is not here. I cannot see him. Okay, that's fine. Okay, then Abdullah, let me try you one last time. Let me try unmuting you. Yeah. Okay, Sidra will. Okay. Okay. Let's just start with my teaching. Okay, we will do the rest of the questions in the next class. Okay, those students who have not gotten a chance, it's okay, we will do it next time. Okay, okay, because I need to start teaching now. Okay, so today I'm going to so we all know the basics of atomic structure. The way you guys have explained answered these questions, I am now convinced that you know at least the basics of atomic structure. And for those of you who still do not know the atomic structure, you can read the book first of all, and then watch my class. The recordings of my class are on my YouTube channel. See if that is helpful. Okay, and then I would also recommend Khan Academy. Khan Academy is a good website. Okay, just type in atomic structure Khan Academy and you will get their videos. Okay, those videos are also very helpful, and if you still do not understand anything, then you are most welcome to ask me. Okay, now let's talk about the relative atomic mass. So we know that the mass is the sum of the number of protons and neutrons. Okay, but why do we use the term relative with it? Why do we use the term relative with it? What does relative mean? What does relative mean? Relative means in comparison or proportion to something, right? So what are we comparing this atomic mass to? Now, if you try to measure the exact mass of one atom, for example, hydrogen atom. Why did we take hydrogen atom as the the standard? Is because it contains only one proton. So we are talking about one subatomic particle. One subatomic particle, because hydrogen atom is only composed of one proton. That's it. Because if you look at the periodic table, you can see that its mass number as well as the atomic number both are 1. So that shows us that it has atomic number 1 means one proton, right? Mass number 1 means it has no neutron. That's it. Okay, so that's why we take an atom. I mean, the scientists took an atom and they tried to weigh it using an instrument called mass spectrometer, and they found out that the mass is 1.7 into 10 to the power minus 24 grams. Now, this is a very awkward number, a very difficult number. I mean, practically speaking, doing all those calculations, life would have been a havoc if we had to deal with such a number. So scientists came up with an easier unit where they equalized this whole thing to just 1. So this whole awkward number is equal to 1 atomic mass unit. So this whole thing, 1 atomic mass unit, is equal to the mass of 1 subatomic particle, which can be either a proton or a neutron. So 1 atomic mass unit is the mass of 1 proton or the mass of 1 neutron. So remember, when we are measuring the mass of an atom or a subatomic particle, we do not use the units grams, okay? We use the unit AMU, okay? Atika, please do not share your screen? Okay. Okay. So now how do we define one atomic mass unit? Now this can get a little complicated. So we define atomic mass unit as 1/12 of the mass of carbon-12. Now, what is carbon-12? That will be your next question, right? What is carbon-12? So, okay. Carbon-12 means that carbon which has a mass of 12. Okay, now your next question might be, so is there any other mass for carbon? Why are we saying carbon that has a mass of 12? Don't all the carbon atoms have mass 12? The answer to that question is yes, there are carbon atoms, the mass of which is not 12. Okay, it can be 11. Okay, so that is because they have different numbers of neutrons. They have different number of neutron, and carbon isotope also has a mass of 13. Okay, so they took carbon-12 as the standard. And why did they divide it by 12? Why did they divide it by 12? Because we wanted to define one atomic mass unit, because we wanted to define one atomic mass unit. So think of it as this. Even if you did not understand this, it's okay. But I do want you to understand the basic concept of what is an atomic mass unit. So let's suppose this is the mass of carbon 12. Okay, so this is 12 AMU. If now I am representing it in the form of a fraction. Okay, now if I divide this into 12 parts, and how do I do that? Okay, if I divide this into 12 parts and assuming that all these parts are equal, okay, then this one part would be 1 AMU, right? So this is what they're saying. So this is 1/12. This is 1/12 of carbon-12. So 1/12 of 12 AMU will give you 1 AMU. Now, why did the scientists come up with such a twisted way of defining AMU? Is because they had to consider a lot of things, which I will not go into the details of, okay? And you don't need to get into those details, but just understand that one atomic mass unit is 1/12 of the mass of carbon-12. Okay, so that's all. That's all about relative atomic mass that you need to know for now. And then why couldn't we use hydrogen? Very good answer, a good question. There were some problems with hydrogen. Hydrogen did not exist in nature in stable forms, and there were other problems scientists were facing difficulty with. And carbon-12, because its mass is little higher, it's 12 times the mass of hydrogen, therefore the measurement of its mass was, I think, more reliable using a mass spectrometer. And there were other reasons as well. So they chose carbon-12 as the standard. Okay, so I will move on to the concept of isotopes. What are isotopes? Now, isotopes, as we just appreciated, and you guys, when you answered these questions, you told me that the number of proton is used as the identification number, right? Why? Because no two atoms belonging to different elements are going to have the same number of protons. That's why we use proton as the identification number. Just like two students cannot have the same roll number in an examination, right? They can have the same name, but they cannot have the same number. So in the same way, atomic number is used as a roll number. Now, we have carbon in two forms. Now let's talk about carbon, okay? One isotope has a mass of 12. The other isotope has a mass of 13. So now let's work this out, okay? If the mass is 12, and by the way, both of them have the same atomic number, which is 6. The atomic number stays the same as long as the atom belongs to the same element. So with this piece of information, what can we deduce? We know that the number of protons is 6. That we know because the atomic number is 6. This also has protons 6 because the atomic number is 6. Okay. But what about the neutrons? What about the neutrons? The mass here is 12, right? And as a few students, Sariha and some other students, they calculated the number of neutrons to be the difference between the mass number and the number of protons. Why? Because mass is the sum of protons plus neutrons, right? So if protons are 6 and mass is 12, then neutrons must be 6, right? Right. Which is obtained by subtracting 6 from 12. So you get 6. So a number of neutrons is 6. But what about this? Here the mass number is 13. Okay, so the neutron would be 13 minus 6, which is 7. So the number of neutrons in case of this carbon is 7. So as you can see that both of them are the same element. Why? Because they have the same proton number, but the number of neutrons since is different, therefore their mass number is going to be different. So such atoms are called isotopes. So let's try to define isotopes together. Okay, let's try to define isotopes together. Isotopes are atoms of the same element which have the same atomic number but different mass numbers due to different number of neutrons. Or you can just keep it simple by saying that isotopes are atoms which have the same atomic number but different neutron number. Simple. Isotopes are atoms, I'm repeating, isotopes are atoms of the same element that have the same number of protons but different number of neutrons. Okay. And this is not the only element that exists as isotopes. Majority of these elements that you see in the periodic table, they are isotopes. So next question that arises in my mind and in your mind maybe, that if carbon exists as 12 and 13, then why in the periodic table have they only mentioned 12? Where did the 13 go? No, what makes you say that that's a standard? So then why did we write 12? Why did we ignore the 13? That's a question. Yeah, so yes, Aisha, good job. This is the average. So now we will talk about how do we calculate the average? And that's where the term average atomic mass comes in. Okay, now these are different terms that you come across. Relative atomic mass means you are relating to a standard atom, which in our case is carbon 12, remember? Now, you can just simply call it atomic weight, or there's another term, which is average atomic mass. So we take out average. Now, what do we mean by average? Now, what the scientists did was they took all the carbon atoms, I mean, not all, but like they tried to get as many carbon atoms as they could from different sources, from different parts of the world, randomly, okay? And then they measured their atomic masses, and then they wanted to find out how many of them are carbon 12 and how many of them are carbon 13, okay? And also if there's a third isotope, because some elements have even 3, 4, 5 isotopes. So they have to find out how many isotopes, first of all, and then randomly picked up atoms, how many would be this isotope and how many would be that other isotope. So let's suppose, now let me give you an example. How do they come up with this average? How do they calculate this average? For example, we have an element and I will give it a symbol A, for example. Okay, this is just for explanation purpose. If I have an element and I will give it a symbol A, okay, and to keep things simple, I gave them the atomic mass of 1 and 2. Okay, so now I took, for example, 10 of these atoms from different sources in the world. Okay, from different sources of the world, I took 10 atoms. I'm just taking random numbers, I mean easy numbers so that you understand easily. Out of those 10 random atoms that I took from various sources in the world, 4 of them turned out to have mass of 1, and 6 of them turned out to have mass 2. Okay, now how do I calculate their average? This is simple math. Okay, this is simple math. Okay, so I will add up their masses. I will add up their masses. 4 of them had 1, 6 of them had 2. I will add them up and I will divide by the total number, right? Isn't that the way you calculate average, right? Sum of masses of atoms divided by the total number of atoms. So I had 4 1, so I simply multiplied 1 by 4. I had 6 2, so I will simply multiply 2 by 6. Okay, so what do I get? 1 4 is 4, 2 6 are 12, 12 plus 4 is 16, divide by 10, I get 1.6. So that is the average atomic mass for this element, for my imaginary element. 1.6 is the average atomic mass for this imaginary element. Now, of the two, which one do you think is more abundant? Abundant means is more commonly found in the universe. Now, out of 10, 6 are A2. 6 are A2, right? So that means this is more common. Out of 10, 6 are A2. That means this is more common and this is less common. So this is more abundant. So the average value is gonna be closer to the mass of the more abundant isotope. The average value that you will get is going to be closer to the atomic mass of the more abundant or the more commonly found isotope. Did you understand this? So 1 and 2, right? So can you see that the average is 1.6? 1.6 is closer to 2 than to 1. Yeah, this is not 12. This is my imaginary element. This is not carbon. Okay. Okay. So I hope this is, you understood this. Now let's solve a question. Okay. Let's solve a question. I just came up with this. Out of any random 100 copper atoms taken from nature. Okay, sorry, no. If, for example, you were given a question, these are the 2 isotopes of copper. Okay, one isotope mass is 63, the other isotope mass is 65. This is their abundance. Abundance meaning what? Like out of 100, if you take 100 random atoms from the universe, from different sources, 69 of them will be copper 63. 31 will be 65 out of a total of 100. Okay, so that means I add 69 63 times and I add 31 65 times. Sorry, 65 31 times, right? Just the same way as I did here. I multiply the atomic mass by the number of atoms that were there in my sample, okay? So when they are saying 69%, that means out of 100, so my total is 100, okay? Out of 100, 69 have a mass of 63. So if I want to find out their total mass, I will add 63 plus 63 plus 63, 69 times and so on and so forth, right? So instead of doing all of that, I just simply multiply 69 by 63 and I will get, I will get what I will get by adding 63, 69 times, right? And then I do the same with this isotope. So the mass is 65 and I multiplied by 31. And the product of 69 and 63 is 4347. Product of 31 and 65 is 2015. and then I add them up and I divide it by 100 and I get 63.62 and I get 64. So that is the average mass value of copper that you see in the periodic tables. In the periodic table, the mass for copper is 64, as you can see, right? So how did we get 64 when their masses are 63 and 65? Why is it written 64 here? So now you know, okay? This is how they calculate, right? I hope you understood that. And if not, you listen to my class again, okay? So let's do one question from your book on this, and let's see if you understand this. Let's do this question. I'm sharing my screen. Okay. Okay. This question. Hydrogen atomic number 1 has 3 isotopes. They can be shown as hydrogen 1,1, hydrogen 2,1, hydrogen 3,1. First of all, what are isotopes? So I just defined isotopes, okay? Or one of you can do this question for the next class as well, but just listen to my explanation first. So the isotope definition, I just told you, atoms belonging to the same element that have the same number of protons, but a different number of neutrons. So that's the definition for isotopes. Now, what is the difference between the 3 isotopes? What is the difference between the 3 isotopes? So who wants to answer that question? Mass number? Yes, mass number is different, but why? You have to keep your answer specific. Yes, Saad, very good. They have different number of neutrons. That's the difference. Yes, Aisha. They are different in their number of neutrons. Good job. Then next part, C. Okay. Hydrogen reacts with chlorine in sunlight, forming hydrogen chloride. Would you expect the same reaction for each isotope of hydrogen, and why? So the question is asking, what is the question trying to ask? First, try to understand the question. They are saying that we just learned about isotopes, right? That they differ in their number of neutrons, but they have the same number of protons and that they have same number of electrons. But will they react the same way with the same substance? For example, if hydrogen is reacting with chlorine to give you hydrogen chloride, will all the isotopes react the same way, or do they differ in their reactions? They differ in their reactions, and why? Please explain. Yes, because the neutrons and protons don't take part in any reaction. Would you expect the same reaction for each isotope? Okay. Yes, because number of neutrons only change, the number of electrons stay the same. Yes. Remember, reactions is the job of electrons. In chemical reactions, it's only the electrons that participate. The nucleus does not participate, neither the protons nor the neutrons. Therefore, since the number of electrons is the same, the reactions are going to be the same. So then, how are the isotopes then different other than the number of neutrons? Are they different in any way that we can observe? Do you have any observable differences between the isotopes? How do they differ then? Okay. Salman Saeed, you're constantly asking for the link of website. The link of my YouTube channel is in the group description. Okay, and Khan Academy, you just write Khan Academy in the Google bar and you'll get it. So does anybody want to answer? How do then isotopes differ if they have the same number of electrons? And so is there any difference? They will differ in what? have the same chemical reaction. This happens because electrons are arranged in the same way. Reactions only involve electrons. Yes, but my question is, if they, yeah, I understand that the chemical reaction is the same, but is there any way they differ from each other? Yes, they differ in their physical properties. Okay, they differ in their physical properties because remember, they are, because they have different mass numbers. So they will have different overall weight. They will have different densities. Okay, they will have different weight overall. Okay, so the heavier isotope is going to be a heavier substance overall, and therefore they will differ in their physical properties. Not all of the physical properties, but yeah, a few of the physical properties, especially the ones that have to deal with their weight and mass, because heavier isotopes, they are heavier. Okay, the difference lies in their mass and weight. And so we have come to the end of our class today. Inshallah, we will continue in the next class. And again, I will assign you questions, okay? And we will do calculations of relative atomic masses, calculation of average atomic masses, and also calculation of relative formula mass, okay? Okay, assalamu alaikum wa rahmatullahi wa barakatuh. How do I get this?